Happy New Year, everyone.
Happy New Year.
Good to see you again, Terry.
Yeah,
Hope you had
likewise.
a
Likewise.
fantastic Christmas. Speaking of fantastic Christmases, this is our first show of 2022. We all had a lovely break, and our wonderful friends at the Space Store apparently had an absolute bumper of a Christmas, which is really, really good to hear. Given our government seems to be throwing parties every week, I mean, hey, why not? But no, they've been observing all the rules all through COVID and doing some fantastic outreach still via shows like this, and obviously what they're doing as well. But their VR experiences and everything they're doing is really good. So if you're ever in the Didcot area, now Didcot is a really fun place. It got voted actually one of the worst places in England to live, but it's right near Harwell. It's right near the most amazing part of the UK in terms of the Harwell Space Cluster. So if you're ever near there visiting the SDFC or the Harwell Space Campus, or if you work at the Harwell Space Campus or anything like that, pop over to the shop in Didcot because they do brilliant coffee, and I'm a real coffee snob. They do really, really good coffee. They have some great talks in store. So just wanted to give them a big, massive shout out and a huge thank you. Again, this is our third year now that we're into doing this show, Terry. And it feels like, yeah,
Yeah.
lockdown continues. Or not, hopefully. So 2021, we did a big roundup at the end of 2021, and one of the big things that we talked about then was the impending launch of the James Webb. And I guess we were all, I mean, everyone, I think, in the entire scientific community and the astronomy community was doing this and crossing everything and hoping that it all worked. And to quote Jeff Goldblum in Jurassic Park, "You crazy fool, you've gone ahead and done it." They did it. It's up there. It's moving out to its Lagrange point. It's unfurled the sun shield, tensioned the sun shield. It's quite amazing. And from my perspective, it's a long story. This and loads of people have talked about the James Webb, and we're going to talk about the James Webb for a good while tonight. Talk about the instrumentation and what it's going to be doing and stuff. And Terry's going to be covering all of that rather brilliantly, I would imagine. Um, from my perspective, it's quite a personal story because around about 10, 11 years ago, I was in New York at a conference called the NEAF Conference, Northeast Astronomy Forum. And it's like a big astronomy event that's hosted by several of the magazines, and lots of people are there. The Meteorite Men are there, and lots of the telescope vendors and what have you. It's a really, really good show to go to if you ever get a chance. It's up in a place called Suffern, just north of New York. And one of the speakers there was a lady called Dr. Heidi Hamill, and she's been very, very involved, as has people like John Mather, who's the PI on James Webb, and Amber Strawn, and various other people, been involved for decades. This is most of their career involved in this. But 10 years ago, there was a real threat that the James Webb was going to be cancelled. Congress were not happy with the overspend, and at the time it wasn't even anywhere near what it is now, but they were really trying to look at where they could cut various programs. And we saw throughout the Obama administration, for example, the cutting of some of the proposed lunar lander programs, etc. with that. And Congress have got a really heavy side on this, so lots of people got involved. So Barb Mikulski, pardon me if I pronounced the name incorrectly, but one of the senators based up in Maryland, who one of her remits was the Hubble, she got heavily involved. So during Heidi's talk, she basically said, look, please talk to your Congress people and get involved, because there's a real threat that this thing could be cancelled. So I kind of took this message back to the UK and got in touch with a journalist friend of mine called Paul Sutherland, and he got it into some of the national press that there was a plan, a plan to cancel this telescope. And then a group of American friends got in touch and said, look, do you want to join in? We're going to set up a campaign called Save the James Webb. And it became this like group of about 8 or 10 of us got involved, and we pushed really hard. We pushed via all the social media channels at the time. It's nowhere near as busy as it is now, but via Facebook and Twitter in its infancy, etc., and really just pushing the message that write to your congressperson. And thousands of people did. And we got a thank you. We got a while it was kind of saved. We all got an email from NASA head office, as it were, basically saying, "Would you like, as our way of saying thank you, to come to Goddard to see the thing being built, to see the thing being put together?" And for the Americans, it was great. For me, it was like, this is a chance in a lifetime kind of thing. So it took about 3 months because you got it's a government facility, NASA Goddard, etc., and to get all the clearances and stuff. But flew over to Washington, stayed with some friends in Washington, and just spent the most amazing few days touring Goddard Space Flight Center, going inside the various facilities, looking at the test and vacuum chambers, etc., and seeing the mirrors kind of just all, the whole system being put together. And you just think, 10 years ago, it was still, nobody knew if it was going to be launched. Even up until not that long ago, we didn't even know if it was going to be successful in launch. And then all of the risk associated with it, with ESA doing the launch with the Ariane, and the Ariane, it's quite a reliable system, but it's not 100% reliable. And getting off the ground, and then the fact that the James Webb could never be fully tested on the ground because it's too big. You always say it's a tennis court size sun shield. To integrate that with the main telescope array and the main mirror array and all of the instrumentation, it was actually impossible. There wasn't a vacuum chamber on the planet big enough to test it in its full configuration. So it had never been tested fully. And even up until a few days before launch, there were still issues where there were joists kind of not supporting things. It's a miracle. It's an absolute miracle. And now that it's heading out there, what's it going to do for us, Terry? What are the amazing things this telescope is going to do?
Well, a lot of people wonder why it's going to operate mainly in the infrared. We all like the lovely pictures from the Hubble Space Telescope and the other Earth-based telescopes and so on. We will get some from the James Webb, but not quite the same sort of thing. The reason it's going to operate mainly in the infrared is that it wants to look back as far as possible towards the very birth of the universe, the Big Bang, and what happened immediately afterwards. And there are a number of issues there, but the main one is that is so far away, and the light, all the radiation, in fact, because of the expansion of the universe, has been stretched, what we call redshift. And most of the light that is coming to us from the events in the very early universe has been stretched from the visible well into the infrared. So to look at the galaxies and the first stars as they were about 13.5 billion years ago, you need to be able to see into the infrared. So it will be looking at the birth of the first galaxies, the birth of the first stars. Even closer to home in our own galaxy, there's an awful lot of stuff in our galaxy that we can't see properly because it's obscured by dust. And infrared light penetrates through dust. So you can see the very early stages of planetary formation of the protosolar disk surrounding stars, and see just how stars first form. We'll also be able to look at a lot of things even in the outer region of our own solar system in the Edgeworth-Kuiper belt, maybe even out as far as the Oort cloud, where things are they're so cool that they are radiating or reflecting in the infrared rather than invisible light. So a whole lot of things that the James Webb can study that we can't study at all from the Earth because the infrared radiation doesn't get through, but that even the Hubble Space Telescope wasn't able to study. There were other infrared satellites up there, nowhere near as powerful as the Webb. Some of them have reached the end of their life anyway. So there's so many things that this telescope will be able to do that no other telescope can do, that it's just going to be groundbreaking, assuming, of course, that everything actually works as planned. It's on its way almost at the Lagrangian point, the L2 point, where it's going to be stationed. That happens, I think, in about 5 days, 4 or 5 days, 23rd of January. But all the instruments still have to be fully tested. And most importantly, the final collimation of all the 18 different segments of the main mirror have to be exactly collimated. And this is something to try and get your head around. The surface accuracy of all 18 of those mirrors working together has to be accurate to the diameter of a coronavirus. Nanometers, about 10 nanometers. I mean, it's mind-boggling. And this all has to be done remotely. Now, because there are 18 different mirrors and they all have to not only be individually adjusted, but then to work as one, that is going to take quite a while. We're not going to get nice pictures back just as soon as it gets to the L2 point. We have to be patient. There's no point in sending back very blurred, disappointing pictures, although they will send some pictures back just to make sure that the optics are working and the transmission system is working. But we'll not get really clear pictures probably until around April or May. But if everything works as it's supposed to, this is going to just totally revolutionize whole various areas of astronomy, mainly what I've already talked about. There's a lot more. We could talk about this all night. Those are the main things. What do you think, Nick?
I mean, yeah, it's amazing. We talk about collimation with telescopes, and any amateur astronomer who's ever tried to collimate a Schmidt-Cassegrain or a Newtonian telescope will know it's, mirror alignment is really important for getting really crisp, sharp images. And we all remember what happened with Perkins-Elmer with the Hubble Space Telescope and the fact that they ground the mirror incorrectly. Thankfully, with this, it's as Terry said, it's a multitude of mirrors. The accuracy, the surface accuracy on the mirrors themselves. I mean, you're talking about atomic level thicknesses of gold, obviously being the most optimal material for picking up the light in the infrared end of the spectrum, which is why it was selected. And people say, why are the mirrors gold? Well, it's optimized around the frequencies of light that it's aiming at. It's things like the Oort cloud. At the moment, the Oort cloud is a theoretical, we believe it's there, but we've never seen anything in it. So could the James Webb finally show us objects in the Oort cloud? Could it pick up this hypothetical planet X that everyone's been saying is out there? And then you've got the whole argument of, well, if it's above a certain size, is it a planet or is it a moon? And the whole issue is surrounding that. But there's another potential. The whole thing with exoplanet atmospheres, the fact that you could detect not the presence of life, but the signatures that would indicate that there could be life on a planet. From the atmospheres of exoplanets on nearby star systems. We know that Proxima Centauri's got multiple planets in it orbiting around it. That's just one star. There's thousands and thousands been picked up by Kepler. So there's the whole cosmic dawn and star formation and galaxy formation, like a few 100 million years after the Big Bang. We may have to completely rip up the textbooks again in terms of what we believe on galaxy formation. There's so much that is riding on this, and the fact that the European Space Agency, and everyone says, it's a NASA, NASA's website. Yeah. It isn't. This is a joint mission between NASA and ESA, and a huge amount of credit has got to be given to the European Space Agency, between the Ariane team and the launch system being absolutely flawless and being so perfect that they've extended the actual lifespan of the James Webb even further because their orbital insertion precision was so good. So massive hat tip on that one. And there was loads of people really concerned. I was one of them. How concerned about that I was. But then, the instrumentation, it's a global effort that's gone into this. Edinburgh University and all sorts of places all over the UK and all over the world have really collaborated. So there's hundreds or thousands of scientists have worked on this. As I said, people like John Mather, who's the PI, this has been 23, 24 years of his life. And with the delays and delays and delays, this thing initially was scheduled to launch like pretty much 10 years ago, or getting on for 10 years ago, but we've had so many delays. It's like Artemis. It's going to be incredible. The thing with infrared as well that we need to be aware of is that the Hubble images are beautiful, and Hubble images were truly beautiful because not only was the data and the quality of the data coming in and captured so good, and let's not forget that the computational capability and the imaging sensors on the Hubble are now decades old. These are not state-of-the-art sensors. Even the James Webb, the instrumentation on it is going on for a decade old because some of this stuff was conceived and had to be approved and signed off way before launch. Some of these instruments have been ready for years and have been almost in cold storage, kind of ready for deployment. So if you take all that into account and then you look at some of the images coming back from the Hubble still to this day that are absolutely remarkable, and we can only hope that SpaceX or somebody is going to be able to deliver a capability to repair the Hubble yet again, or do something with it, at least put it into a higher orbit until we can work out what to do with it. The thing that always struck me was, and it was a great quote from a magazine editor that I used to work with, who said that the Hubble's images are beautiful, but the ESA Herschel images look like somebody's thrown up on a dinner plate. The colors were all over the place. Now, this is the problem. With infrared, obviously at the kind of longer wavelength end, the resolution that you're going to get from an instrument the size of the Hubble compared to the Hubble, which is operating into the ultraviolet and the optical end of the spectrum, some minor bit into the infrared, is going to be nowhere near as crisp. But with the James Webb mirror being so much bigger, those images are going to be crisp, and hopefully the image processing, you're going to want to get as much science from it, but the public at large are going to want to see beautiful images. They're going to want to see the pillars of creation, as it were, or the Horsehead Nebula. Some of the images that came out of Herschel were stunning, but some of them really did look pretty awful, and people were like, what is this? Why have we put so much money into this? So I know NASA will do this, and I know ESA will do this. You've got to be able to deliver not only fantastic science, so detection of exoplanet atmospheres, detection of Oort cloud objects, etc., all of these wonderful things, but if you just show a little tiny red dot on the screen and say, this is the furthest star we've ever seen at 13.18 billion light years away, people are going to go, meh. If you show them an image like the Pillars of Creation, they're going to go, wow. And that's what I hope it's going to do as well, is not only inspire people from a scientific point of view, but inspire people, in the way that the Hubble did. The Hubble is almost like it's a common word in our language now. It's like Google.
Mm-hmm.
We talk about telescopes, we talk about the Hubble, and we don't, we know that Edwin Hubble was, a historic figure, etc. And there was all the controversy, don't forget, just before James Webb was launched, with the whole cancel culture thing that's going on of, should it be called named after James Webb because of his beliefs and views? Well, it's like anything that's in our past, we need to learn by our mistakes and move forward. And James Webb, for all of his failures, and everybody has failures. My kids remind me daily that people like Gandhi was this and Martin Luther King was that. Nobody's perfect, but James Webb got us to the moon. It was absolutely incredible, and that's what we need.
I got away error message there, but I'm still hearing you.
Yeah, still hearing you. Good.
Right.
I got a message.
You're talking about the international aspect, and I'm delighted to say that one of the principal or co-principal investigators on the MIRI instrument, the mid-infrared instrument, is actually a guy I know well from Dublin, and he's giving a lecture to us, the Irish Astronomical Association, on the James Webb tomorrow night, so that'll be very timely. But the instrument that he's involved with, the MIRI, the amazing thing about that is it'll be operating at only about 7 degrees above absolute zero, because that's where you need basically to have your greatest sensitivity. And how do they achieve that? That's where the big sun shield comes in. And this is one of the mind-boggling things about that. The temperature difference between the sunward side and the shaded side on the final layer is 347 degrees centigrade. 347 degrees C, not Fahrenheit like the Americans like. That is the amount of shielding that sunshade will provide. And then there's obviously a helium refrigeration system basically to cool down the MIRI instrument, in particular, even cooler than that. But that sunshade, which they say as well known, really, the size of a tennis court. And of course, that all had to deploy on the way out. This is where we were biting our nails and so on. And then the mirrors unfolding. And we just couldn't believe it that everything was working so perfectly. Now, I hope that's not putting the curse on it, because there are other things still to happen. Yeah. But basically, so far, everything has worked just like textbook. And it's full kudos to everybody involved.
Yeah, it's flawless. The level of testing that was undertaken. And that sun shield, those layers that are the size of a tennis court, are also about the thickness of a human hair. I mean, It's ridiculous. It's like, the thinnest sheets of kind of Bako foil you can imagine, as it were, but vastly, vastly thin. I mean, it's literally whisper thin. And to be able to tension it in multiple axes and get it, all of the separate layers, spaced perfectly, deployed perfectly. It is an absolute marvel. And the fantastic thing as well is that even amateurs, and we're going to be talking about this a bit later with people getting telescopes for Christmas, even amateurs have been able to image this thing as it's been heading out. Yeah. And the beauty is, as it's been getting bigger, deploying the sun shield and deploying the telescope array, as it were, its brightness is changing. It's an absolutely remarkable thing to see. And some of the images, even you could see that it wasn't a stellar object. You could see that
Yeah.
it wasn't round. It was an elongated shape. So again, hat tip to everyone. And even when it's at its Lagrange point, you'll be able to image it. We imaged the Herschel telescope using the Fulks 2-meter telescopes when it was kind of lost for a while, and we managed to recover it a few years ago. So it's going to be one, hopefully, for 10, hopefully more years, that's just going to deliver astonishing science. We could talk about this for days, but hopefully by
Absolutely.
the next show, as you said, it'll be out there, and then we'll follow this through probably through till April, and then hopefully bring you some of the first images when they come back, and just celebrate really, and absolutely in the wake of. Don't forget, all of this has been done during COVID as well. You think
Yeah.
about the challenges. Unless you're working at number 10 and you're throwing a party, but the challenges of just even getting together and doing any real work is so complex, and they've managed to launch the most advanced telescope ever into orbit. Yeah, amazing. Anyway, so we've done about 20 minutes on this. Crack on. This is a great story as well. So this is the Chinese discovery of actual water on the moon, and we've seen water before, Terry, but this is a first from the Chinese Chang'e 5 lunar
Yep.
lander.
My pronunciation may not be quite as precise as yours. I have no Chinese whatsoever. Yeah, ice on the moon is something that we've known about for quite a while. Some of the craters near the poles of the moon, particularly near the South Pole, are deep enough. And with the orientation of the moon relative to the sun, there are parts of the bottom of some of those craters where the sun never ever shines, even during a whole lunation. And orbiting satellites have detected ice frozen in the bottom of those craters. So we knew that there was ice there. At least we were sort of 99% sure, because this was just being detected from orbit. The disadvantage of that is that those craters are not necessarily in the best place where you want to set up a base. There are pros and cons. So some of the pros are, for example, that the crater rims get perpetual sunlight, but the crater floors are in perpetual darkness. But anyway, to come on to the latest one of Chang'e, the spacecraft actually detected water, not as ice, but well, it was, I suppose, ice in the sense that it's frozen, but it was in the rocks on the surface, and it was sampled on the surface. In the area we talked about this quite a while, the Oceanus Procellarum near the Rumker volcanic outcrop area. And the significance of that is that's the youngest lava outflow, basalt lava, on the moon, as far as we know, about 2 million years old. That's very old compared with things on the Earth. But then the moon doesn't have tectonic activity and plate subduction and the surface being resurfaced. So that is young in terms of the moon, the lunar surface. And the spectrometer actually detected water in both the form of H2O and the OH hydroxyl molecule. So there's water not only in the deep craters at the lunar poles, but in the regolith. Now, not very much. We're talking about parts per million, maybe 180 or so parts per million. But since you can basically, if you have to process large amounts of the lunar regolith, you can get a significant amount of water out of just the dirt, basically, that's lying on the moon. And you don't have to go to the poles to do it. On the equatorial regions as well, it's there, assuming that this area is relatively typical. So water obviously is essential for any sort of a long-term lunar base. We need it for drinking. More importantly, for the long-term future, if you want to use the moon as a base to head on out to Mars and so on, you can break it up into hydrogen and oxygen and use those as components of fuel. So it's a very, very significant finding. There's enough on the whole of the moon, taking the whole of the lunar surface, to do anything that we would possibly want to do in terms of lunar exploration. Obviously, if you have to process a lot of the regolith to get any significant amount of water out, you're going to need machinery there to do that, but that is doable. So instead of just having ice detected from orbit, we now have definite evidence of ice, water, both the water molecule and the hydroxyl molecule in the surface of the moon. So that's a very significant finding.
Oh, it is. I mean, it's yeah, and it's spectroscopic identification as well. I believe it was about 2.8 microns that they, or 2.85 microns they detected it at. What's really interesting is that it's the first in situ one, as you said, on the surface. Has been orbital analysis, which has demonstrated that there is water. And obviously, the Apollo samples, when they first came back, it was, oh, the moon is dead, the moon is dry. But then, as the instrumentation and the kind of scientific method improved, those lunar samples brought back 50 plus years ago are still delivering fantastic science now, and they're able again to demonstrate that, you know, things that we weren't spotting 50 years ago are now being detected in those lunar samples. So and obviously China have done a sample return mission as well. So it's interesting to see where this is heading next, because NASA have got the CLIPS missions, their commercial lunar program missions, and they've got the Viper, which is their own rover, which is going to be hopefully going to be looking for volatiles, as they're known, like water and other volatile materials. So there's a lot more with this. I think this is kind of the first steps back to, you know, really understanding the moon and, you know, building a proper research scientific base on the moon. And if you want an analogy, Antarctica is probably your best analogy. That's what everybody I think is hoping for. We're going to have multiple stations, you know, the Russians, the Chinese, the Americans, Europeans, etc., multiple stations dotted across the moon doing hopefully really solid scientific research, because that, you know, it's only 240,000 miles away. It's going to be a lot easier to do that on the moon than it is on Mars, no matter what Mr. Musk says and all of his fan people. So let's see where this one goes. But I thought it was a really good story as well, and
Yeah.
massive hat tip to China on that one.
Yeah, it's also a very interesting area for other reasons. It's what they call the creep terrain, KREEP, K for potassium, REE for rare earth elements, and what have I got? No, sorry, K. I've got mixed up here. Anyway, it's very interesting geologically. I'm not a geologist, as you can see, but that area was chosen because it was young and because the spectrum indicated that it had these interesting elements in the structure. Yep. So again, as you say, well done to China on that.
Yeah, so moving on to our next story, less well done to China. So, as we predicted, so if anyone's been listening for the last few years, we've got a bit of a bone to pick on constellations and stuff, and we're not the only ones now. It's going up to parliamentary level, and it's being discussed at very, very high levels, because, you know, once the US military got involved, which they now have, the US Department of Defense are getting really, really concerned about this and are now throwing money at commercial operators to see what they can do about the space debris issue. And the DoD are looking at lasers, they're looking at all sorts of different things. And then you had last year, late last year, that we had the Russian ASAT test, which put tons more debris into orbit. And just before this announcement that we're about to talk about, China announced that one of their satellites had been knocked out by some debris. And we've had multiple EVAs on the International Space Station cancelled. We've had it's now the last month, I believe, over 70,000 CAMs, collision avoidance maneuvers, happened in the space of 1 month. And China complaining to United Nations and various other bodies, anyone that would listen, about Starlink. And the irony of that is that they then go and announce their own version of Starlink, because obviously we've been predicting for quite some time, and it's open secret really, but working as I do in the defense sector, this is a big concern for the defense sector. We have, China now saying that they're going to put up a mega constellation of approximately 13,000 satellites. Now, Elon Musk's Starlink is in that same kind of ballpark. And from what I've seen with the Federal Communications Commission and the Federal Aviation Authority and the kind of Western US-based and European-based legitimate filings for satellite launches, there's upwards of 80,000 satellites now being proposed to be put into low Earth and medium Earth orbits. Now, it can't sustain that. It's Elon Musk was saying, oh, space can handle billions of satellites, and then Professor Hugh Lewis at University of Southampton and various other people did some calculations and proved it was complete lies, and it can't. And the problem is that you could have the best artificial intelligence and CAM systems, collision avoidance systems, known to humanity, but the fact remains that there's still 100+ million pieces of debris, ranging from the size of a grain of sand up to the size of EnviSat, which is a European Space Agency satellite that's drifting around aimlessly at the moment because it's dead, and that's the size of a school bus, a US school bus. So all of these things moving at 17,500 miles an hour, around about 8 kilometers a second. Impact velocity on any one of these could wipe out a satellite. Impact velocity on something the size of a grain of sand could kill an astronaut. And this is becoming more and more of a problem. And now China have announced that they're going to put their own mega constellation. And the bizarre thing is some of the operations for this are coming out of Wuhan. And we all know how wonderful the science coming out of Wuhan has been for the last 2 years. Let's not even go there. It's I just beggars belief. The fact that you've got the astronomy community up in arms about this because of the inherent impact it's having on ground-based observations, not just in the optical spectrum but in the radio spectrum and everything else. Now you've got China, which are going to be using various frequency bands, Ka band, etc., and the regulatory oversight that we get out of China is, let's forget it. I mean, they won't even admit what they're doing in, Xinjiang province. So trying to get them to comply with international regulations, it's going to be amusing. We don't even know what Russia are planning yet, apart from, potentially on the Ukrainian border. Let's not go into the politics too much there. But up in space, this is a major threat. This is a major issue. And China obviously are responding to Starlink in that they're not going to want their 1 billion plus citizens using a US network with an unregulated kind of satellite communication internet link. I very much doubt you'll ever be able to, bar probably smuggle one in, but to get a Starlink satellite dish operational in China, it's just not going to happen. Even though Musk's whole pretense behind Starlink and the commercial model, there's been discussions of whether or not it's even going to succeed, because unless he gets Starship running, and the launch cadence on that's going to be pretty high, and he's going to be able to cram that thing. Don't forget, Starship can launch over 100 tons to orbit, so this is way bigger than the Falcons that are currently launching Starlinks at a rate of 50-60 a go. He's going to have to be launching every week just to make Starlink commercially viable. Now, by commercially viable, what we're talking about here is a currently $499 dish and then a $99 per month subscription. Obviously, the prices are going to come down across the board because they always do. But the whole altruistic, we're doing this for the benefit of humankind, is just a myth. When you've got half the planet, sub-Saharan Africa and various tracts of Asia and the South Pacific, etc., who barely scrape by on a few dollars a day. You only have to look at what's happened in Tonga recently, where SATCOMs was completely taken out. Satellite phones, communications by an undersea volcano that kind of has wrought havoc in Tonga, and we're all praying that and hoping that the Tongan people are getting through this, because it's catastrophic. All of this plus these mega constellations, and the argument could be, well, if you've got optical based satellites, it's fantastic and you can image all these disaster regions. Yes, but you don't need 80,000 of them. It's just insane. And we predicted this with China. I don't know what you think, Terry, but it's just going to hell in a handcart.
Absolutely. The thing about Starlink is that's private enterprise. That's Elon Musk, nothing to do with the US government. Yep. As far as we can tell, this Chinese proposal has the backing of the government up to a pretty high level. And of course, they also have on a smaller scale their own private enterprise stuff, Galaxy Space. They're due to launch 6, which is, tiddling compared with what the major proposal is, but nevertheless there's private enterprise even in China going ahead. But the whole point is the Chinese government should not be driven by purely commercial considerations like Elon Musk. They should be aware of all the pros and cons of this, and yet they appear to be backing this. So I can't read the mind of Chinese politicians, so you have to make up your own mind about that. But it does seem, as you say, incredibly risky, especially as they're now putting up their own, have already put up their own space station. They had a very close miss with that, with 2 Starlink satellites. So, it just seems to be incredibly short-sighted.
Well, the thing is as well with communications, the ability to use laser relays and laser-based comms in orbit as well is becoming more and more prevalent because of obviously the issue with hacking. We've seen some pretty significant cyber attacks, even quite recently in Eastern Europe. Entire nation states practically being taken out in the past, nuclear power facilities. So this is becoming more and more of a growing threat as well. And if China are looking at, what China do, and not wishing to cast aspersions, their science is great, what they've been doing with the lunar landers, etc., is fantastic, but make no mistake that they're going to be looking at observational capability, at spying capability. There's a whole raft of things that could be implemented as a kind of an aside in some of these satellites, and we just don't know. And what the ability to control the internet and to control all of the messaging within China, and it's potentially expanding territories like Taiwan, etc. Is really interesting, because they don't obviously want to use a US controlled and US based network, even though it is a commercial and private enterprise with Elon Musk. We've got iPhones, and the, quite happily sold in China and distributed in China, and the whole issue with Apple and the regulatory hoops that they're having to kind of jump through just to be operational in China, and then the fully controlled internet. I think you were in China as well for the eclipse, Terry, back in 2009, and I can remember sitting in a hotel in Shanghai just completely unable to get certain things, like parts of the BBC just didn't exist, and you think, okay, this is a little bit spooky. And then you think, should I use a VPN to get in and out? But then you just almost kind of looking over your shoulder all the time. And it's not to say that any Western state is any better. We talk about what happened with the WikiLeaks issues, and what happened with the United States government. It's not saying one is any better than the other, but they're both as bad as each other when it comes to chucking up junk into space. We don't need 80,000 satellites to get internet on the ground. The speeds that everybody's whooping about at the moment with Starlink are, they're impressive, but fiber optic cables, 5G, HAP systems, high altitude pseudo satellites, none of this is going to cause the problem that we're going to have with satellites, where a couple of impacts and that's it, it's game over. You only need a few large scale impacts at strategic orbits, and you're going to have so much debris up there that you just won't know what to do with it. And the ASAT test, as you said, Terry, has already put the ISS at risk, and Starlink has already put the Chinese space station at risk. So it's one that will go on and on and on until somebody dies or a catastrophe happens. And it kind of leads us on nicely, when we're talking about catastrophes, to the hot film of the moment, as it were. I don't know if any of our listeners have seen this film yet. I watched it just before Christmas when it came out, and I loved it. And from what I can gather, pretty much all but one or two kind of nerdos of the science community loved it as well. Now, yes, there's a lot wrong in this film in terms of the science. Having done tons of astrometric data reduction on comets, in the past, and like finding comets and finding asteroids, etc. Our team at Folks found, I believe it was 22 asteroids in the end. So we know what we're talking about with this. Astrometric data reduction is not something you do on a chalkboard atop Mauna Kea in an open dome, an open dome that's going to freeze you to death anyway. You're not going to be using the Subaru telescope and have the control room there. There's a lot that's wrong. There's a lot that's kind of fictional and mythical with this film, and doing orbital dynamics calculations on a chalkboard, you're going to do them on a computer, and you're going to send the data to the Minor Planet Center, and the Minor Planet Center are then going to give you rough calculations, and then you're going to do follow-on observations for days, if not weeks, and get an improved arc in terms of the orbit of the comet, as it is in this case. First night or so, you could say, yeah, it may get close to the Earth. Second night, it's actually getting a bit close to the Earth. A few weeks in, you're going to be like ringing up the alarm bells. And the fact is that you're not going to be able to hide this at all, because every amateur astronomer and all the observational astronomers around the world, the professionals and the amateurs, anyone amateur with a half-decent telescope is going to be able to detect a comet out to Saturn's kind of orbit, as it were, quite easily. And that's where we're talking about here. We're talking about something that, with 6 months to go, you're looking at roughly the orbit of Saturn or Jupiter before it hits the Earth. The premise of the film is brilliant, though, because the premise of the film is basically talking about the whole culture that we now have, where things explode on social media really quickly. It could be a celebrity gets a new tattoo, or a celebrity, changes their hair color, and how important that is compared to potentially the end of the world. And the two scientists in this, brilliantly, in my opinion, played by Leonardo DiCaprio and Jennifer Lawrence. Jennifer Lawrence is a kind of PhD student who discovers a comet. Um, Trying to get this message across that this is a really serious problem. And this is what the climate scientists have been trying to do for a decade. They've been trying to get the message across. This is a really serious problem. And the issue you've got with climate science is it's the frog in the saucepan kind of analogy, where you're turning up the heat slowly and the frog's slowly dying, rather than you drop a frog into a boiling pan, it'll hop straight out. With a comet with 6 months to go, there's nothing we can do. You can, it doesn't matter how many trillions of dollars you throw at this, there is pretty much nothing you could do to deflect something that's as big as the one in this film away from the Earth. And that's a fact. And that's the problem, is that 6 to 9 months is typically how long you get from detection to, the orbit of the comet crossing either the orbit of the Earth or coming in close to the sun, whipping around the sun, having its orbit changed by sun's gravity, etc. Potentially, as happen, or sometimes comets can kind of fragment, and you get all sorts of fragmentation events and bits drifting off here, there, and everywhere. There's nothing we can do about it. Asteroids, yeah, better chance. Typically, we're going to have a bit longer. But you look at some of the online data and the scales of how big an object has to be to cause a catastrophe. And as I said, going back to Tonga, you don't have to look at that shockwave, from an undersea volcano in Tonga. And then if you imagine that a 140-meter wide asteroid or comet is going to create something bigger than that, it's going to absolutely be catastrophic. 140-meter wide iron asteroid hitting a city, you've got no more city. And if you've got 8 million people in London or 20 million people in Tokyo or whatever, that's 20 million people dead. End of story. And every year we celebrate Asteroid Day, and Brian May and all these famous pop stars and celebrities get involved, and it's fantastic. And that's what I think the greatest thing is about this film, is it's raised awareness yet again, like Armageddon, in its cheesy, nasty, horrible, scientifically inaccurate way did in the 90s with Bruce Willis landing on a comet. Not going to happen. Horrible film, but it's one of those, switch your brain off, chew some bubblegum, get some popcorn and enjoy it. Deep Impact was a much better film in terms of the science. This one is, again, a better film. I won't spoil it and talk about what happens toward the end, but it's well done. It's criticised for being overlong. It's criticised for the science not being particularly accurate. Forget about that. It's a work of art. It's a artistic endeavor. It's trying to get people aware of not only the threat of an asteroid or a comet hitting us from space, but the general issues that we've got these days with celebrity culture and all of the things surrounding that. And that, to me, is the great message of this film. I don't know what you think, Terry. I know you've still got to see it, Terry.
I haven't seen it. No, I had to. I went through a car changing phase just before Christmas, which for various complicated reasons ran on actually into the new year before I was sort of fully okay with having a new set of wheels. So looking at films was not number one priority. Anyway, I would disagree slightly. I think with the new telescopes coming online, like the Vera Rubin telescope and so on, we have a pretty good chance of detecting something well before it reaches the orbit of Saturn. But even so, even if you 2 years warning for a comet coming in, a big comet, you're not really going to have a chance to do anything. And either way, I wonder, is this actually going to be counterproductive? Because people will say, well, look, if it's coming, there is damn all we can do about it. Put your head between your legs and kiss,
Kiss goodbye.
Yeah. But in many circumstances, many cases, we might be able to do something, particularly if it wasn't all that big, and if we detect it when it's, say, out around the orbit of Neptune or so on. So I entirely agree with the theme of the film, that we need to get away from the celebrity culture and an anti-science outlook, the way climate change is being denied still by so many people, by the way the COVID outbreak was being denied, as not that it didn't exist, but that it was trivial. It was just flu or something by people like Trump and Bolsonaro in Brazil, with horrible consequences for their own population because people weren't being treated or vaccinated as soon as possible. So I think its message in terms of how we try and counteract the anti-science culture and start to trust the scientists. Now, there's been a huge amount of debate going on about whether you trust science or whether you trust the scientists. What I say is you trust the scientific method. If science makes a mistake, it learns and it moves on and it betters the science. That's what happens. So yeah, I'm looking forward to seeing this. I agree with you entirely about the other films you've mentioned. Even Gravity, I thought, we do agree about the Kessler syndrome, but there's some of the things in Gravity that were a bit daft. But as long as they bring it to public attention, then they're doing the job. So yeah, I'm looking forward to seeing it.
Yeah, it's the artistic endeavor. It's like Apollo 13. There was lots wrong with that film. The way that they portrayed Jack Swigert was horrific. It was just so badly done. Jack Swigert was an incredible pilot, and you talk to people like Jim Lovell and Fred Hayes, and have done many times with Fredo, and it's just horrible. But then there was so much that was perfectly accurate in terms of the measurements of Jim Lovell's house and how it looked, and the launch system. Apparently Buzz Aldrin saw the film and said, where did you get that launch footage from, when they'd CG'd and composited in the Saturn V launch. It's the same with Armageddon. And the thing with this film, they had Amy Mainzer involved as scientific advisor, and all through Hollywood's history, Jerry Griffin, one of the Apollo flight directors, was one of the consultants on Deep Impact. They do get people involved, but they're trying to tell a story, and they're trying to tell it obviously in a way that is engaging and exciting for the public. And they're not going to say, well, we're going to send the data to the Minor Planet Center and wait 6 weeks until we can get a proper orbital calculation. It's just not going to happen. I think the issue I've still got, Terry, and I know you talk about LSST, Vera Rubin, various other telescopes coming online. The issue that we've got is that some comets, as we know, you look at Comet Leonard now, it's spectacular in the southern hemisphere, right? If we've got a high inclination comet that's coming in from the southern hemisphere, bless them, the southern hemisphere don't have these facilities. There's not a lot. Obviously, you've got some of the telescope systems on the equator, but it's going to be more difficult. CSIRO, I remember years ago, cancelled their entire kind of early warning asteroid and comet detection system. I remember talking to Terry Lovejoy, who's amazing amateur who's discovered numerous comets, and it just begged belief that they were doing this. And you're going to have the SKA, etc. But I don't know. It's still, you look at Comet Leonard, and we've got some very advanced telescopes out there. But don't forget the field of view on a lot of the really good telescopes. The Hubble's got a postage stamp. You hold your hand out at arm's length and you hold up your little finger. That's the field of view of the Hubble. It's a big sky, and you're trying to survey all of that. And if it was a case of, yes, we're going to be able to detect something, don't forget, before comets light up, before they hit the ice line, as it were, and they start to sublimate, they're 5 times darker, or 20% the luminance of albedo of coal. Some of the darkest things imaginable. So I'm not quite as optimistic as you that we're going to find them all. It'd be great if we could, and that could be, again, one of the things that the James Webb could accidentally pick up on. It'd be interesting. One of the best films, I think, for kind of looking at the panic scenario, this was Deep Impact, because despite the president saying on national television what a bottle of water cost you yesterday is what it's going to cost you tomorrow, people profiteer, and you only have to look at COVID to prove that. You look at the whole ridiculousness of toilet roll at the outset of COVID, and some guy in Australia, remember, buying up 30,000 toilet rolls or $30,000 worth of toilet roll and stuffing it in his garage, and then trying to sell it for an extortionate rate. People will do this. People will try to profiteer, and they won't understand. What's the point? You can make as much money as you like. If in 6 months' time you're going to be dead, you can have a whale of a time for 6 months maybe, but what's the point? So let's hope. But if you haven't seen it, anyone listening, it's a great film. Like I said, the science isn't perfectly accurate. I mean, I could pick holes in every single minute of it. But the bits where the two astronomers are talking to the Kate Blanchett character and the kind of Fox News style kind of news anchors, as it were, and the presidential response with Meryl Streep, and she's brilliant. She's like a female Trump on steroids. It's really, really accurate in how it captures this relationship between the scientific community and the sensationalist press, etc. So absolutely brilliant film. I loved it. It's not the best film ever made. It's not The Godfather Part 2 or The Shawshank Redemption, but it's still a very, very worthy film. And we don't tend to do film reviews that much on the show, but we thought this would be a good one to pick up on. Anyway, after we just said don't look up, now we are saying look up.
Yep. Absolutely. And with excellent timing, the International Space Station, well, right, we're going in a different order. I was going to mention that the International
Oh
Space
no, do the
Station,
ISS first. Yeah.
right, is going to start another series of evening passes over the UK and Ireland tomorrow. And we talk about it in terms of the risk from the satellite debris and so on. So it is there. You cannot fake it. It's up there. You can deny the Apollo moon landings and all the rest of it. But you can see the ISS for yourself. You use a smart app on your phone or any number of websites. One of the ones I like, it's very handy and easy to use. Heavens Above, just Google or search whatever way you like and you'll find the details. And a clear night, you see it going over, and it is absolutely amazing that thing, the size of a football field, with permanently crewed, 5, 6, 7 or so people on board, doing research, not just there for the show. You can watch it, and the real experts can actually take photographs of it that show the detail of the structure of the solar panels and the various modules. So there's absolutely amazing stuff can be done, even by amateurs. But yeah, that's something that'll be crossing our skies for the next couple of weeks or so. But to go to the thing that was coming up there on the screen a moment ago, counting stars in the Pleiades. There are a couple of things that are of interest in that. The Pleiades are also known in our culture as the Seven Sisters, because according to tradition, anybody with good eyesight in a dark sky can see the 7 brightest members. I don't have time to go into the mythology of who the 7 sisters were in Greek mythology, but that's the name. Now, can you see 7 or not? Anybody who has a Subaru car will probably know that Subaru is Japanese for the Pleiades, and they only have 6 stars. So is it 6 or 7, or is it more or less? In my heyday, when I had good eyesight, when I was a lot younger, my record for seeing the Pleiades with the naked eye, really trying in a really dark sky, was 11. But that's not by any means the world record. Maybe it's been changed, but it's around 14 or 15, looking from incredibly dark skies on top of a mountain or something like that. But now with increasing light pollution, it's very rare to be able to see 7 or even 6. So it's a way of testing your eyesight, testing the amount of local light pollution. The moon is going to be a bit of a problem. The next couple of days is just past full, but wait a couple of days when the moon isn't in the sky and go and have a look at the Pleiades. How do you find them? If you can't find Orion, then you definitely need some sort of an app on your smartphone or something. But most people can find Orion. You take the 3 stars in Orion's belt and follow them up to the right, the top right. You come to an orange star called Aldebaran, and you go on past it along the same line, and you come to this beautiful cluster of stars. And it definitely looks like a little cluster of stars. If you've got binoculars or a telescope, they're absolutely spectacular. See how many you can see in that group. Now, where do you start? Where does the group begin and end? Well, roughly speaking, across the diameter of the Pleiades and the 7 bright stars is roughly 1 degree. That gives you an idea of how big it is, about twice the size of the moon. And if you take the brightest star there that you can see roughly in the middle of that group and go out roughly 1 degree radius from that. That is a sort of an unofficial size of the cluster. See how many stars you can count in that. It's a way of testing your eyesight. Use specs, obviously, if you wear them, and a good test of how dark your sky is. So that's one of the beautiful sights in the winter sky, and you can use it, as I say, to test your eyes and the sky conditions. Going on to other things in the same area, the winter sky is absolutely glorious. We have Sirius, the brightest star in the whole sky. We have Orion, the most spectacular constellation in the whole sky. And there are a number of others there. And we can learn quite a lot about basic stellar astronomy just from looking at the colors of those stars. Now, I can't describe the positions of all of these, but you can again find them from any sort of an app or a star atlas or online mapping. If we start with Betelgeuse, which is the bright red star on the top left of Orion, as we look at it, it is obviously red. We talked a lot about it about a year ago when it was behaving rather oddly. It's a supergiant star, about the size of the orbit of the Earth around the Sun, but it is definitely red compared with most of the other stars. Not a true red, but definitely reddish. And the reason for that is that it's a lot cooler than most of the other stars that we see. Now, you would think, red must be hot. Red hot is really hot. Yeah, but it's not as hot as blue white hot. And we'll come on to that in a moment. So as stars get hotter, the temperature goes with the color that they radiate most of their light in. And Betelgeuse is a relatively cool star. Surface temperature about 3,000 degrees. That's roughly the temperature of, say, an electric ring on your hob in your cooker. That sort of temperature. Or if you look inside the grill or something, when the grill's on full, that's roughly the sort of color that you're seeing, although it won't be as hot as the surface of Betelgeuse, but it's giving you an idea of the color. So it's one of the cooler stars that we can see in the sky. I mentioned Aldebaran a moment ago. Go back to the stars in Orion's belt, go up to the right, and you come to a bright orange star. It's slightly smaller, well, a good bit smaller than Betelgeuse, but still a good bit bigger than our sun. And it's about 3,500 to 4,000 degrees in surface temperature. So it's orange, noticeably not white, but not quite as red as Betelgeuse. If you look almost directly overhead in these winter evenings, sort of look at Orion as if he's standing upright, and then go right up above that until you come to the zenith, you come to another one of the very bright stars, Capella. And it is noticeably yellow in color, not pure white, but not orange. And it's about the same surface temperature as the sun, roughly 5,500 to 6,000 degrees. Of course, the temperature in the centers of the stars are many millions of degrees, but we'll not go into that now. So that is also a giant star, a bit much bigger than the sun, not as big as Betelgeuse, but intermediate in terms of brightness. Then I mentioned Sirius, the brightest star in the sky, and you find it easily enough, not just because it's so bright. If you go back to Orion's belt and follow that line down to the bottom left, the first bright star that you come to is Sirius. Now, the thing about the color of Sirius is it's so bright, and from our latitude, it tends to be fairly low down, that it twinkles an awful lot, and it can actually flash different colors. You can see blues and reds in it, depending on the atmospheric conditions, as the refractive index in the atmosphere breaks the light up into different colors. But overall, it's basically white. It's a temperature of about roughly 11,000 degrees in centigrade. Then we go to even hotter ones towards the blue-white, and still in the Orion area. If you look at Bellatrix, which is the star on the top right of Orion, his top right shoulder as we look at him, you're into a blue-white star. It is much, much hotter, 20 to 30,000 degrees. And the hottest of all are the stars in Orion's belt. They're what we call O-type stars, or OB, just on the verge or the boundary between the O classification and the B classification. And they have temperatures up to about 48,000 degrees centigrade. Now, because they're a little bit fainter, sometimes the color isn't just that easy to see, but if you have a pair of binoculars and you look at them, you will see that they are definitely blue-white in color. So they're all in that one area of the sky. You have the complete range from relatively cool stars like Betelgeuse up to the very hottest stars that you can see easily with the naked eye. Don't have time to go into the astrophysics of why they're that different color. Basically, it's the rate at which they're burning their fuel. But it's more complicated than that, as Nick, I'm sure, would agree.
Oh yes, oh yes. I mean, it's a wonderful thing that you can basically look at the colours of the stars, and you're doing, as Terry said, kind of stellar astrophysics. So it's really quite interesting. And if you get into things like spectroscopy, look at this image. It's beautiful. Robert Gendler is one of the best images out there. During our next show, because we're going to touch on it in this show, but I think it's something we need to just kind of talk a lot more about. We'll probably do it in the next show. If you got a telescope for Christmas, or you got your kids a telescope for Christmas, some of the things you may see on the boxes of these telescopes, especially if you've bought them from your camera shops, etc., you'll see these glorious images on the outside of the box, kind of Hubble-like images, and there'll be pictures showing you what you can see with your telescope. And the reality sometimes can be a bit of a disappointment. I mean, these images that you can see, some of them were taken with quite small telescopes, but you do need really good mounts and good cameras and stuff. So we'll talk probably a lot more about that during the next show. But it's one of those things, especially with the ISS, with a pair of binoculars, a good sized pair of binoculars, or if you're really handy and you kind of think about the bazooka method, as it's known, where you basically hold a refracting telescope in your arm and track the ISS across, you can see detail. As Terry mentioned before, there's images like Thierry Legault and various other people all around the world who specialize in imaging the International Space Station, and they've got so good at it, they even managed to image astronauts out on spacewalks, out on EVAs. When you've got spaceships like the SpaceX Dragons, etc., docked with it, you can see them. So we'll talk a lot more about that, I think, during the next show. But it's the best time. Now is the best time, from kind of late January, well, Christmas time, through to around about March. It's a really good time to get the telescopes out. Obviously, it's very cold at the moment, so make sure you wrap up warm if you're going to be outside with a telescope, or build an observatory if you've got the inclination. Lots of people are building out buildings because they're working more from home. Turn it into an observatory, get a roof that you can kind of push back. There's some great ones if you watch programs like Grand Designs and Small Spaces, etc. There's some really good ones that people have built. So just get out there and have a look at the sky, because it is absolutely stunning. And we say this every time, but it really is. And now, in the summertime, it's a lot more difficult. It doesn't go dark, and Northern Europe, etc., and where we are in the UK and Ireland until quite late, 10, 11 o'clock at night, and even then it doesn't really go dark. If you're up in Scotland, it never goes really truly dark. Now is a really good time to get your telescopes out and or even binoculars, and just enjoy it. And if you've got kids, take them out. It's amazing seeing like the ISS, or even the Orion Nebula. The beautiful thing about Orion, and Terry's just saying about that now, it's one of the few things that you can get a pair of binoculars or even a low power telescope, look just below the belt. There's a kind of fuzzy patch. That's the Orion Nebula. That's a star forming region, and you can see it's just this gigantic gas cloud 1,500 light years away. That it's amazing. So get your telescopes out, enjoy the night sky is what we can say. Speaking of enjoyment, in case you're wondering, I am wearing my Space Store t-shirt. I'm in quite a cold office because it is -4 outside at the moment, and it's a little bit chilly. I've got the heating on in here, but it's not quite getting it up to temperature, so I've got a jumper on. But going back to our friends at the Space Store, again, this is our 3rd year doing this, and we've got a loyal band of listeners. Thank you so much for sticking with us and enjoying the show. And if you've got any questions, please don't hesitate to ask in the chat. We really do like having questions in the chat, or stick them on YouTube, or send them to either Terry Moseley 2 on Twitter or Nick Astronomer on Twitter. We're more than happy to always answer your questions, and keep looking up, as they say. Any final words, Terry?
We were going to talk about telescopes, but we'll do that in the next issue. We just run out of time.
Yeah, a little bit. Anyway, massive thanks to our kind of backroom team. We have a really good laugh and chat with just before we come on air. We found out that pretty much all of us are of Celtic origin tonight, so that was quite fun, given what's happening in England at the moment with our government. But yeah, just enjoy the sky, enjoy the science. Go and see that film. Don't Look Up. If you haven't got a Netflix subscription, you can take out a free one for 7 days. Just do it to see that film, because it's a lot of fun. It'll teach you kind of a lot about orbital dynamics as well. Enjoy it, and we'll see you in 2 weeks' time.
Yep. Happy New Year, everybody.
Happy New Year. Cheers.
Bye.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Stuff.
Adios, amigos.
Bye all.